Good day everyone, I am Justin Mistadana together with my partner Leandro Garcesto, and today we will presenting our project in number theory. Our presentation focuses on problem number 8, which instruct us that from item number 6 we can obtain a proof that 1 times 2 plus 2 times 3 plus ellipsis plus n times the quantity of n plus 1 is equal to n times the quantity of n plus 1 times the quantity of n plus 2 all over 3. Hint, observe that quantity of m minus 1 times m is equal to 2 times the quantity of m taken 2. For our step 1, we are going to check the truthfulness of the hint. So first, we have here quantity of m minus 1 times m is equal to 2 times the quantity of m taken 2. By applying multiplication property of equality and multiplying both sides by 1/2, we have now quantity of m minus 1 times m all over 2 is equal to the quantity of m taken 2. Quantity of m taken 2 is equal to m times the quantity of m minus 1 times the quantity of m minus 2 factorial all over 2 factorial times the quantity of m minus 2 factorial. Since we have common factor which is quantity of m minus 2 factorial, we can divide it out, and also take note that we are using here binomial coefficient. Next, we have quantity of m taken 2 is equal to m times the quantity of m minus 1 all over 2. Since our second step and final step are the same, therefore, our hint is true. For our step 1.2, since we already proved that the equation quantity of m minus 1 times m is equal to 2 times the quantity of m taken 2, we can express the equation to have quantity of m minus 1 times m plus 2m is equal to 2 times the quantity of m taken 2 plus 2m. The reason of this is addition property of equality. If you are wondering where this 2m came from, it's just the difference of quantity of m plus 1 times m minus to the quantity of m minus 1 times m. And by applying distributive property, we have now m squared minus m plus 2m is equal to 2 times the quantity of m taken 2 plus 2m. And by adding like terms, we have m squared plus m is equal to 2 times the quantity of m taken 2 plus 2m. And by factoring, we have now m times the quantity of m plus 1 is equal to 2 times the quantity of m taken 2 plus 2m. Despite adding 2m both sides, the equivalence of this equation remains the same. For our step 2, we can apply some identity here. So we have summation of m times the quantity of m plus 1 from 1 to n is equal to the summation of the quantity of 2 times m taken 2 plus 2m from 1 to n. So it is also equal to 2 times the summation of m taken 2 from 1 to n plus summation of 2m from 1 to n. By applying here summation of rule number 3, and lastly we have here summation of m times the quantity of m plus 1 from 1 to n is equal to 2 times the summation of m taken 2 from 1 to n plus 2 times the summation of m from 1 to n. For our step 3, we are going to evaluate 2 times the summation of m taken 2 from 1 to n, and by using problem number 6 proven statement, so we have 2 times the quantity of m plus 1 taken 3, and by applying binomial coefficient, we have 2 times the quantity of m plus 1 times n times the quantity of n minus 1 times the quantity of n minus 2 factorial all over 3 factorial times the quantity of n plus 1 minus 3 factorial. And by dividing out common factors, which is quantity of n minus 2 factorial and 2, so we have quantity of n plus 1 times n times the quantity of n minus 1 all over 3.
For our step 4, since we're done evaluating 2 times the summation of m taken 2 from 1 to n, we can now proceed with evaluating 2 times the summation of m from 1 to n. We have been given a proof that the summation of m from 1 to n is equivalent to the quantity of n times the quantity of n plus 1 all over 2, and by using the substitution, we are now given the equation 2 times the summation of m from 1 to n is equal to 2 times the quantity of n times n plus 1 all over 2, to which we can divide out 2. By doing so, we are now left with 2 times the summation of m from 1 to n is equal to n times the quantity n plus 1. For the next step, we will now substitute the results of our steps 3 and 4. Before, we had the summation of m times the quantity m plus 1 from 1 to n is equal to 2 times the summation of m taken 2 from 1 to n. plus 2 times the summation of m from 1 to n. We now have the summation of m times the quantity m plus 1 is equal to the quantity n plus 1 times n times the quantity n minus 1 all over 3, added by n times the quantity n plus 1. Note that in order for us to be able to perform addition to both terms, we need to first find their LCD or their least common denominator, where in this case it is 3. By doing so, we now have the summation of m times the quantity m plus 1 is equal to the quantity n plus 1 times n times the quantity n minus 1 all over 3 plus 3 times the quantity n times n plus 1 all over 3. Next is to simplify the equation. Since both terms have a denominator which is 3, we can now combine or add their numerators, giving us the equation the summation of m times the quantity m plus 1 from 1 to n is equal to the quantity n plus 1 times n times the quantity n minus 1 plus 3 times the quantity n times n plus 1 all over 3. As you can see, we can still use factoring in this situation because both have the quantity n plus 1 times n. Factoring it out will give us the quantity n plus 1 times n is multiplied by the quantity n minus 1 plus 3 all over 3. We can then simplify it further by addition, and we now have the final equation, which is the summation of m times the quantity m plus 1 from 1 to n is equal to the quantity n plus 1 times n times the quantity n plus 2 all over 3. This proves that the equation 1 times 2 plus 2 times 3 plus ellipsis plus n times n plus 1 is equal to n times the quantity n plus 1 times the quantity n plus 2 all over 3 is true.
Pure Mathematics is in its way the poetry of logical ideas by Albert Einstein. Thank you so much for listening, and God bless.